Let's go over the basic or intrinsic types, the types that are built into the language. There are two kinds of built-in types. There's the family of the integer types and the family of the floating point types. The difference between them is the floating point types can support fractional values, but the integer types are only whole numbers. What I have here is two columns listing the names of the type and also the size in bytes. Now, a byte is the basic unit of storage on a computer. It's the equivalent of 8 bits. 8 bits is enough to hold 256 values, including 0. The types that are built in, that are integers, include the bool, B-O-O-L, which stores true and false, char, which is big enough to hold the equivalent of one letter, called a char character. Bool and char both are sized 1 byte. A short integer is 2 bytes, so it has 65,536 values. Because 2 bytes is 16 bits, and 2 to the 16th is that number. The integer, the int, is 4 bytes long, and that is roughly 4 billion different values. Then the long, or long int, is 8 bytes. That's a really, really big number. Starts with a 9 and has a whole bunch of digits after that. And then the long. Now, it's also 8 bytes on modern computers, so there's no difference really between a long and a long. Among the floating point types, there's the float, which is stored in 4 bytes, the double, which is stored in 8 bytes, and the long double, which is stored in 16 bytes. The range of values that can be represented by floats is huge. By the time you get to a double, you can represent more values there than the number of atoms in the known universe. And long double is just ridiculous, but I would recommend that you don't use long double unless you really, really know what you're doing, because computations using long doubles take a long time. They're very slow. In the olden days, you would want to avoid floats entirely because of the slow speed of calculating with floats. But now with today's hardware, you could use doubles pretty freely. They're going to be basically the same speed as floats. So don't have any worry about using doubles unless you're constrained for space, since a double is twice as big as a float. Declaring variables has the following syntax. You start with the type of the variable and then the name of the variable, followed by a semicolon. Alternatively, you can declare more than one variable of the same type by separating names by commas. So here's the type of the variable, name 1, comma, name 2, as many as you want, followed by the semicolon. You can also assign a value at the same time that you're declaring the variable. An example of that, or a prototype of that, is the type name. The name of the variable equals and a value of that type, followed by semicolon. Now let's look at some examples of these. Okay, so in the first case, here's that type. It's going to be an integer, and here's the name. So I'm declaring an integer, an int, named counter, but I'm not giving it an initial value. So here's an example of giving an initial value. I'm declaring a variable called habanero. Let's just correct that, a habanero. Scoville, and I'm giving it a value of 200,000.0. So 0.0, the point is what's giving it making it the floating type value. And so 200,000.0 is the initial value of habanero underscore Scoville. Okay. The next line is an example of declaring more than one variable at the same time. When you do that, they all have the same type. Okay. And finally, here's an example of declaring more than one variable at a time and assigning initial values. Other things to point out for now, go over again in a moment, that each of these values here, each of these values here, that's an example of a literal, and that's an example of a literal, and that's an example of a literal. So when you're explicitly giving the value of something, you can call that a literal value, because that is the value, literally. There are some rules concerning how you can put together names of variables and names of functions. There's also something called classes and structs and other things. They all follow the same naming rules. These are the rules. You can only have the lowercase a through z, the uppercase a through z, the digits 0 through 9, and the underscore. One more rule is a name cannot begin with a digit. There are conventions for how to construct variable names, function names, and things like that. And the conventions are simply that. They're conventions. They're rules that we all agree to. They're not built into the language. You can violate these rules if you want to, but if you do violate the rules, then you'll be the kid who doesn't get picked for the baseball team. All right, so functions and class names and structs, you don't know what those are yet, but don't worry. Functions, classes, and structs begin with a capital letter. Variables that are constants, and we'll learn about that, constants, they can't be changed, those are typically in all caps. And then finally, there's the case where you want to make a variable name or a function name out of multiple words. So pick one of the following two styles. One style is called camelback, and it's called camelback because, as you see here, there's a mixture of uppercase and lowercase, then uppercase and lowercase. So here's a better example. It's a variable. I know that because it begins with lowercase t. So this is a sample. So up and down and up and down, that's your camelback notation. You can also have a standard by which you separate words in a variable or function name using the underscore. So the sample being here. This is a sample. Now, which one should you use? Well, if you're coding on your own, then you choose. However, once you join a team, then you should adopt the style of the team. Okay? Otherwise, you'll be that kid nobody likes. I used the word literal before, so let's explain again what a literal is. When you're giving an actual value, that's an example of a literal, as opposed to, let's say, mentioning a variable name. So 931 is an example of a literal. It's an int. And it differs from 931.0 in that 931 is an integer. It's a whole number. 931.0 is a double. If you want to make a literal that is specifically a float, then follow the last digit with the letter F for float. So to repeat that, so you have 931 is an int. but the point zero makes it a double, and the point zero F makes it a float. Now, a single quotation mark surrounds a character literal. You may find instances where you see two characters inside single quotes, but to be legal in dollars to donuts, that first character is a backslash or a backslash. Those have different meanings. When you see those two, when you see a character literal that begins with a backslash, the second character, the two together make a single character. Right? Now, when you see a double quote with letters in between, that's going to be a string literal, and that's kind of complicated because a string in C means one thing, and a string in C++ means something else, and we'll cover that later on. Specifying values for bools is straightforward. It's lowercase TRUE for true and lowercase FALSE for false. Now, remember that bools are part of the family of ints. So the value for false is 0. And the value for true is anything that's not 0.